Hello. In my previous video, I talked about the history of what I call the English units of length, the inch and the foot and the yard and the perch and the furlong and the mile and so on. Um, and in this video, I'm going to talk about the metre. And again, I'm going to focus on the aspect of the history that I find particularly interesting as a mathematician. Of which the first, of course, is that it's decimal. So I'm going to start by looking really at the prehistory of the metre, and in particular, the history of decimals. So decimals give you a great advantage over other fractions in that you can go all the way from tiny to huge just by shifting a decimal point. If you don't have that idea, and if your idea of quantities less than one is that it's that just fractions like a half or three quarters or whatever, then you almost inevitably end up with a whole load of different units for different scales, like the inch and the foot and the yard and so on, and whose ratios would not necessarily be powers of 10. But once you have the idea of decimal fractions, it becomes possible to do very much better. So let's look at how that arose. So decimals arrived in the 13th century, having been invented in India in the 7th century. It took a long time to get here. And even that was only for positive integers, really. So no idea of decimal fractions at that point. Decimal fractions arrived a couple of hundred years later from the caliphate centered in Baghdad in the 10th century. Um, but they didn't take off immediately. So, sort of 100 years later, Francois Viette said this remarkable thing. Sexagesimals and sixties are to be used sparingly or never. Thousandths and thousands, hundredths and hundreds, tenths and tens, and similar progressions, ascending and descending, are to be used frequently. So he's arguing for the decimal system, including decimal fractions. But what he's arguing against is sexagesimal fractions. Who would have believed that? That's really odd. So the sexagesimals were invented by the Babylonians and got around the world in the same way. We still use them, of course, for degrees and for that's why we have 60 minutes in an hour and 60 seconds in a minute and so on. And so sexagesimals were used for fractions. It was the Greeks who started doing that. And so when decimals arrived, they got something to beat. There were sexagesimals to be beaten. And really, it was Simon Stevin's book, a decade or so, well, a few years later, Deciende, I don't know how you pronounce that, but it means tenths, really. Um, and he spread the word. And that was an influential book, and people did start using decimal fractions for numbers. Although, interestingly, he used a terrible notation for these decimal fractions. And even now, the notation hasn't settled down completely. And I'm sure you're aware there are countries where they use full stops and commas differently and what have you. Um, but Semyon was ahead of his time. He did propose the decimalization of length. And again, that's a great advantage if you can express length from the tiny to the enormous just by moving the decimal point. That's a lot easier than all these yards and perches and what have you. So the other property of a meter, which may not strike you immediately if you don't know the history, is that it's based on a natural unit of length. So what's meant by natural unit of length is a unit of length drawn from nature. So we have a natural unit of time, which is the day length. That's drawn from nature. Um, and so the search was on for something similar for length. In the 17th century, Gabriel Mouton proposed using the nautical mile, which is that's 1 arc minute around a great circle, 60th of a degree around a great circle on the Earth. So that's natural in the sense that it depends on the size of the Earth. Um, and by this time, they were aware that not all great circles were the same length. And so Gabriel Mouton proposed the longest one, which is the equator. Well, that's a bit silly, really, because it's not at all easy to survey the length of the equator because most of it's either at sea or in jungle. And so it's really hard work measuring how long the equator is directly. And so that idea was never going to catch on. Around the same time, Jean Picard proposed the length of the seconds pendulum. So this is the pendulum whose period is 2 seconds, actually. So it goes one, two, tick, tock. And that is about a meter. And he proposed that as a standard. Um, and of course, people became aware that that wasn't going to work either because that's not quite constant all over the Earth. So that was never going to fly either. But those were the sort of about the ideas that were fermenting away in Europe around the time that the history of the meter really starts in the French Revolution. So why did it start there? Well, I think there are a number of reasons. One of which, of course, is you've got a revolutionary government. They're reshaping the whole of France. They're prepared to move fast and break things, as Facebook would say, and so reformulating creating a new system of measurement was sort of child's play compared to creating a new government. So that's maybe one of the reasons. Another reason I think is that apparently, well, in England at that time, there was a well-established tradition of having a standard yard, which was used all over the country, and so the country did have a standard unit of length. That was less true in France, I believe, that there was still a bit of a tradition of different parts of France using different lengths, and the sort of um, grand vision that the revolutionaries had of the future would naturally have encompassed the idea that everybody should be using the same units of length and other units, of course, weight and whatever. Um, and so it would have come naturally to think of that. They were very much internationalist in their thinking as well. So they were from the beginning thinking about an international unit of length, not because they were imperialists, really. That came later with Napoleon, um, but because they wanted to spread their sort of Enlightenment ideas of rationality and what have you. So anyway, one for whether those are real reasons or not, it did start in revolutionary France, in the middle of the revolution. So the Bastille had been stormed, but the king still had his head. There was still a king, nominally at least. Um, so it starts in 1790, and the first proposal was to find a new length as the length of the seconds pendulum. Aware of this problem that it wasn't the same everywhere, they said, well, at the latitude of 45 degrees. That cuts out a lot of the variability, but not quite all of it, actually. So it still isn't really good enough. Um, and a year later, they dropped that idea. I think more because of some feeling of unease that defining length in terms of time wasn't necessarily a terribly smart thing, because one's idea of what a second is might change. Maybe you wanted to measure length more accurately than you could measure time. So this wasn't going to be a good idea. So they abandoned that idea and went for going back to the size of the Earth, basically. And they said, okay, so the Great Circle um, arc from the North Pole to the equator going through Paris along the meridian was going to be defined as 10,000 kilometers. Now, that, of course, is one of the silliest ideas that any scientist has ever come with, ever, because now they had to send an expedition a quarter of the way around the world to find out how long their fancy new unit of length was. But before exploring that, let me just show you something rather cute. Did you know that? To a very high degrees of accuracy, 100 kilometers is 54 nautical miles. And that's not a coincidence. Um, so if you ever want to know how long a nautical mile is, that's how long it is. Um, and the reason for that, of course, is this. So if the world had been a perfect sphere and the revolutionary definition of the meter had stuck, well, then that 10,000 kilometers along that meridian is 90 degrees of arc, which is 90 times 60 minutes of arc, which is 5,400 nautical miles. And so 100 kilometers is 54 nautical miles. So, in fact, according to the modern definition, 100 kilometers is 53.99,568 nautical miles. A nautical mile being defined as 1.852 kilometers exactly and by definition. That is what a nautical mile is. So, one of the amusing features of this subject is that the abbreviation for nautical mile is the same as for nanometer. Um, I don't suppose there's ever in much danger of confusion. Anyway, back to the story. We've got this daft definition. So we send an expedition not all the way from the North Pole to the equator, but from Dunkirk to Barcelona, which is a reasonable start, to measure how long this arc actually is. But they got impatient with that because you see it took 6 years. So in 1795, they used a provisional length and set up a standard based on an earlier expedition. But once these guys got back and told them how long it was from Dunkirk to Barcelona, they calculated the length of the whole arc from the equator to from the North Pole to the equator using a figure for the eccentricity of the Earth of that, which isn't bad, um, and um, and then it created some standards, two platinum standards and 12 iron ones. And then the meter took off because it really was a good idea. Um, so the first country outside France, I think, to adopt it, more or less, was this Cisalpine Republic, which was set up in the Alps in northern Italy. This republic was set up by Napoleon, and it adopted a modified form of the metric system based on the Cisalpine cubit, would you believe? So if you saw my previous video, you'll know that a cubit is this distance originally from there to there, fingertip to elbow, which is about half a meter. Um, and so they defined this Cisalpine cubit um, to be half a meter. A little bit later, it spread through the Holy Roman Empire alongside the creation of the German customs union. I don't know whether you knew about that, but that was an earlier European customs union. And obviously, you're going to have a customs union. It makes a lot of sense to have standard units across it, lengths and weights as well, of course. And so that's what they had. I think Portugal is the first of the countries that still exist beyond France to adopt the meter, and that was another few years later. And it spread everywhere, really. Most of European countries followed suit. Spain and Portugal spread it around Latin America and around the world. Um, quite a long while later, there was this meter convention of 1875, and the meter was formally adopted as an international scientific unit of length. So scientists would use it and with communicating with one another throughout the world. So really, it had basically won the battle by then, and it was the world standard length. But let's see what happened since then. Um, so in 1899, those standard meters that had been created were replaced by platinum iridium bars, which were then kept around the globe. And the standards specified what temperature that you were to measure them. These bars were to be held on rollers, so that if they and they were to be held and they were to be measured at exactly 0 degrees centigrade. So that was what the standard said. Um, 1960. So there was a decision to move away from a completely arbitrary metal standard to one based on a wavelength, and these different chemical substances were considered, but krypton 86 won, and the meter was then defined to be that many wavelengths of a certain spectral line. I have no idea what the argument was that persuaded people that krypton was the one to use. But anyway, it was. Um, More recently still, a very strange thing happened. At least it seems strange to me. In 1983, the speed of light was defined to be that many meters per second. Uh, right. A second was defined to be, so now we're using a different chemical, it's cesium-133, and the ground state hyperfine transitions, whatever those are, well, apparently 9 billion of them in a second. And that is now the modern definition of a second. And so the meter is now a derived unit, and we're back as we were right at the beginning, with the meter being defined by means of the second. But I guess we're now in a situation where nobody's ever going to get um, measurement of length more accurate than measurement of time. So I think we're okay there. And then, well, all the other units around the world sort of fell into line and got metricated. The first that I'm aware of, the first big one was the nautical mile, which, as I've mentioned already, got defined in terms of kilometres. In 1959, the yard got defined to be that many meters. And that unified, if you saw my previous video, that unified the British and American feet, which up to that point had been slightly different lengths. Astronomers are funny people, aren't they? So, 1984. The light year isn't really a unit that proper astronomers use, I don't believe. It's sort of used by amateurs. But anyway, it got defined to be this many meters. Um, and that is actually the distance that light travels in a Julian year, would you believe? That's 365 and a quarter days, not the Gregorian year that we now use. So that's rather strange. And that, by the way, is 9 petameters. So one of the strange things about this is we have all these prefaces like mega and giga and peta, tera, and which we're accustomed to using in some circumstances, but we don't seem to use them for meters. Nobody really talks about megameters or indeed petameters. Um, Now, the real astronomers use one of the units they use is the astronomical unit, which was defined to be this. Originally, that was the radius of the Earth's orbit, which of course is nowhere near constant anyway. It's not even circular, but that's the definition of an astronomical unit now, which is about 150 gigameters. I know why don't astronomers talk about gigameters? People would know how long an astronomical meter unit was if they did that. So I got a vague idea of what 150 gigameters looks like. I've no idea what an astronomical unit is. Um, Similar, the parsec got defined to be, now this is really odd, this many astronomical units. This is the only unit I'm aware of that's an irrational multiple of a meter because of this pi on the bottom. And this is really peculiar. Well, that, by the way, is about 30 petameters. So uh, a parsec's about 5 light years, about 3 light years. So the parsec's peculiar. So in principle, it's the distance from some distant star to us, where the angle is 1 second. And this is an astronomical unit here. So, is it this distance or that distance? Well, that's what they would be if, and you can see there's not much difference. I mean, it's neither of those actually. It's this one. So this isn't a triangle. It's a segment or a sector. I can't remember which is which, but anyway, it's this thing. And this astronomical unit is a curve. Not very curved, of course, but it's the radius of a circle that has 1 astronomical unit arc length opposite a 1 second angle. That's really bizarre. So let's have a quick look at what happens in America. So one of the iron standards, those original ones, was adopted by the US Coast and Geodetic Survey in 1805, right at the beginning of the story. Um, and they used it. So this is more significant than you might think, because this body was not just responsible for mapping the coast of the US, but it became the body that was responsible for standards generally, and scientific standards. And in 1830, Congress decided to create uniform standards for length and weight in the United States. Presumably, up to that point, the individual states had their own standards. Their chief official, who I guess was head of this body, proposed the meter, the metric system, but Congress adopted the British system, which I find rather odd because you'd have thought at that point in time Congress would have been rather anti-British and pro-French. But there you go, they adopted the British system. In 1866, Congress legalizes the metric system. So you then could sell things by the meter and the kilogram or what have you, and supplied each state with a set of metric standards. Fat lot of good that did. 1875, they not only attended this convention, they actually signed the resulting document. 100 years later, it became the preferred system of weights and measures for United States trade and commerce, and still nobody took any notice. And they still haven't got there. Yeah, but don't be too smug, because neither have we. Oh, by the way, this is a nice little poster from 1897 in America explaining the metric system. It's quite nice, actually. You might like to look at that. You pause the video and look for longer if you like. The story in Britain is sort of similar, really, except that it starts even earlier because right at the beginning, the French revolutionary government offered the UK Parliament the opportunity to join in a joint development of a global decimal measurement system. And they sort of accepted, but then backed out a year later. Why, I don't know. Opportunity missed, perhaps. During the 19th century, though, British scientists, who of course were central in the development of science generally, played a leading role in setting up the metric system. In 1863, surprisingly, the metrication bill, which would have made metric system the official system in Britain, passed the first and second readings in Parliament, but then fell. In the 1860s, the scientists adopted CGS, which is the metric system. 15 years later, 15 attended this meter convention, which set up the metric system worldwide for scientific use. But it didn't sign up, oddly. I don't know why not. A little while later, though, Parliament legalises metric units for all purposes. Um, and in 1995, Parliament bans imperial units for use in comets, with some exceptions. You might think that would mean we weren't using them anymore, but no. The most famous exceptions, I suppose, are actually to do with volume rather than length, and that was pints used for selling draft beer and milk in returnable bottles. But the length one is miles on the road, so we still measure distances on the miles in miles. All the signposts are in miles, and speed is measured in miles per hour still. Why Parliament didn't put a time limit on this thing and say, okay, you can carry on using your imperial units for the next 10 years, but then we're going metric. Who knows? Anyway, so there are some people who use silly units. Well, anything not metric is silly to my mind, but there you go. So aviators, this is odd. They use nautical miles horizontally and feet vertically. Bizarre, can you get? Astronomers, of course, we've talked about use as astronomical. They don't use metric system. They use astronomy parsecs and what things like that, not petameters. Americans, of course, generally, and before you get too smug, us too, um, and some other people as well who use their own old-fashioned units. Well, Liberians, of course, would be using American ones. There you go. That's the history of the meter. I hope you enjoyed it.